G'day there, you're watching the Aussie BIM Guru. Today I've got a fairly complex tutorial on Dynamo and Revit, and specifically how to get your floor plans into Power BI by converting some data and file types. So we're going to learn a lot along the way. I hope this is a useful tutorial for you. So I do have an original tutorial about getting Revit floor plans into Power BI, but the workflow was a little bit more manual and clunky than the one that I've come across recently. So I'd like to firstly thank Pierpaolo Canini for sharing one of the algorithms I'll be using during this script in order to do some segmentation. He actually shared his workflow with me, and there are some similarities to how he solved the problem as well. He actually built the SVG or shapefile in its entirety using text blocks, which is pretty impressive. I'm going to take advantage of a custom node to save some steps. In this case, I did use this website before called Synoptic Designer for Power BI, where you can put in a shapefile that doesn't necessarily have to have any information populated. And you can populate an ID and a name for these areas, as we're calling them. They're essentially polygons, and you can also draw them as well. But the problem is this process was entirely manual. So I saw a presentation from the San Francisco Computational Design Institute. And again, I'd like to also obviously thank them and Achintya Bhatt, who did a presentation on a stadium that she was designing. And one step I spotted was she said that instead of using Synoptic Designer, she actually managed to successfully pass an SVG file some data from Revit, which was very impressive. I had tried this in the past, and I'll be honest, I failed. The reason why was there was a couple of things I was missing. One of them was that all the SVG or shape objects are required to be in the form of polygons, at least in the workflow that I saw. Originally, I was trying to pass in polycurves, which are a different shape class. So in this case, this does actually enable the workflow. As well as this, she was reading and rewriting some of the shape data files, so some of the shapefile data, which is pretty impressive. So instead of using Synoptic Panel or Synoptic Designer, she was actually splicing this file with data from Dynamo, which is pretty cool. So I thought I'd build this all into one complex workflow and share it with you. So for me, it was a bit of a eureka moment when I saw that presentation, and then it all sort of came to from there. So it's important to discuss polygons and segmentation. In this case, we are going to be using an algorithm to solve a problem with some types of polygons or polycurves. In the first instance, a basic polygon is typically made of straight edges with a distinct start and end point to each segment. This way, when you write the polygon's definition to a shapefile, you're essentially just instructing it to go from a set of points to another set of points continually. Polygons don't typically support things like arcs or splines or shapes within shapes, which unfortunately are sometimes things that rooms will have. So we are going to implement an algorithm, the one that was shared with me by Pierpaolo, to solve this problem as well. And a shapefile might look a little bit like this. So you can see that each row is essentially a set of instructions for each shape that's being drawn. In this case, they're in the form of polygons. And this is after I've spliced in the ID of the element from Revit as well. But from there, we're essentially just instructing it with a row of points to follow. And the output will look a little bit like this. We'll have a visual that will interact with our data in Power BI. So we're going to be taking the rooms from a Revit model by level, obtaining their boundaries and segmenting them where they're curved. We're then going to form polygons from these and export them to a shapefile. This will just be the first part of the series, which will actually take a little bit longer than it probably looks. There are a few complex steps in here. In the second part, I think actually the second part's at the end. We'll talk about the second part later. But that's where we'll splice some data to our shapefile. Anyway, we're working with some custom packages here. We're working with data shapes in order to create a user interface to start a fast script. I think this is really important for a complex script like this, which has a few steps to go through. As well as this, I'll be using a couple of nodes from my own package, Crumple, and also the package called Illustrator, which is actually quite an old package, but the node that we're using still works in at least Revit 2020, where I'm using it. So I'm using Revit 2020.2.3 and Dynamo 2.3. Anyway, let's dive in. So I'm just going to jump into a Revit model, and you can use any Revit model you want really. Now in this case, I'm dealing with a model that has a few splines and arcs. So they're not necessarily going to be elements that can naturally become polygons, because if we look at this room boundary, we can see some of these edges are going to be arcs, which is going to be a problem. So if you can find a model that does have some arcs in the rooms, this will be better because this will actually show you how the segmentation algorithm will solve this problem. Anyway, let's jump straight into Dynamo. And I'm going to start a new script. And I'm firstly, obviously, just going to save my script. And I'll just call this working. I'm going to go to manual mode because I'm going to start by building a user interface to start off my process. Now I'm going to need to collect a few different things to begin my script. So I'm going to expand my data shapes package, go to the UI section. We're going to be obviously forming a multiple input form plus for the user interface itself, but we need some buttons. So in this case, I'm going to go to the input section and I'm going to be collecting, in this case, 5 inputs. So the first one in this case is going to be a directory path. This is going to be where we write our shapefile to. After this, I'm also going to collect a text box. And in this case, I'm actually going to collect 2 text boxes. But one of them will house a number and one will house a text field that will populate. One of them will be the name of our file and the other one will be the segment division for when we segment our arcs and our splines. In this case, we also need a file path. This is going to be where we're going to draw upon some Excel data potentially. But for now, I'm probably going to leave this out of my user interface until the second part. The last thing we're going to need is a little bit more complicated, and that's a list view. As you can see, a list view is a little bit more complex. But I'm just going to put these all together into a list. So I'm going to collect all of these input buttons. Obviously, we haven't built our input buttons yet. And we're going to feed this into the input slot. Let's start going and setting up our fields. So most of these are quite simple. For directory path, I'm going to create a code block and I'm just going to call this directory for the name. And I'm just going to prompt the user to set their path. And I'll make this the input name and this the button text. For my first text box, my input name in this case will be segment length. So this will be the distance that we divide segments by. Our default text in this case is going to be a number. So it's going to be the string form of 500. And we'll just say that it's true, that it's a number entry. I'll just copy this. And now we're going to set the file path or the file name for our shapefile. And in this case, I'll just call this, shapefile name. By default, I'll just call this raw data. And it's not a number entry in this case, so it's false. Our file path for now is just going to not be used, but this will eventually be used to collect the Excel data for our rooms. But we'll come back to this in part 2. So this will just be Excel file path. Default path won't exist, so we'll leave that. And the button text will just be also set path. So we'll just copy this. So we've built 4 buttons in this case. The 5th button is a little bit more complex. So what we need to do for our 5th button is collect all the names of the levels in our model, because we're going to let the user pick from all the levels on the model and say which levels do you want to source the rooms from. You could also source all the rooms in an active view, but in this case I find this a better method. So in this case I'm going to have to get a category by name. And the name of the category, oops. I'll copy here instead and see if it's faster. I find the search in Dynamo can be a little bit slow sometimes, unfortunately. But in this case, we're looking for levels. And we're going to get all elements of category. And from these, we're going to get their name as a string. So we're going to need to use element.name. And if I run this, I should have a list of all the names of the levels I can possibly have in my model. I'm going to use this for both the keys and the values for my levels. For the input name, I'm just going to call this select levels, because this will let the user pick the levels that they wish to source their rooms from. I can then populate a few rows. Let's say in this case that I want maybe to say that the height will be 200. And I'll just add a true and a false so I can connect these up to their corresponding rows, because there's a whole bunch of conditions for how a list view behaves. So I'm going to say my height is 200. I'm not going to highlight in view. I won't activate display mode. I won't show element count. There'll be no default value indice. In this case, I will sort, and I won't show IDs. I just got a cut on my computer there. So now we've built all the buttons for our user interface. All we need to do in this case is just populate the data for our input form. Sorry, I just had a cat coming on the laptop. So we're going to create a code block, and we're just going to call this generate SVG file. So this is the title of our interface. For our run button, I'll just call this generate. I'm going to say that the toggle is always true. The cancel button just says cancel. And I'll make the size 700. I'll make it actually 800 by 400. Just need to make sure I've got a semicolon there. And now I can disconnect all my inputs. You can also add your logo as an image path if you wish. In this case, I'm not going to. So if I just save and run, at this point, we should see some inputs. So now we can see, now that my interface is refreshed, I can pick my directory path. So in this case, I'm just going to pick my desktop. I can pick my segment length, which I'll say is 500 by default. I'll also keep the shapefile name just as raw data. I'll set a path for my Excel file. In this case, I'll just create a new Excel file, and I'll just save it to my desktop. So we have just a dummy file to point to for now. Just onto my desktop. I'll just call it book 1. Close Excel, and we'll point to that. And in this case, I'm going to collect the rooms from carport, ground level, and lower ground. So basically my ground floor plan. I'm going to generate, and at this point, we should receive our inputs out of the user input section. So I can see now I have a list and a sublist. What I mostly care about is this sublist where I can collect all my names of my levels. And with these, I'm going to match all the rooms that are relevant. Now with rooms in Dynamo, you have to be careful. If you collect all the rooms in your model, you might sometimes collect the unplaced rooms as well, which can cause a lot of errors when you're trying to process rooms that technically don't exist in Revit. They exist in the schedule, but not in the model. So in this case, I'm going to look for a node from my custom package for Crumple. And it's going to be rooms by placement. And this node is essentially built to filter. Obviously typing in the node's name is not good enough of a match. So rooms by placement. And this node just runs on its own. Once you run it for the first time, it will basically split rooms into 2 lists. All the placed rooms in the model and any unplaced rooms will be filtered out. In this case, I'm going to get the parameter value by name from each one. And I'm going to get the name of the level. So I'm going to search for the placed rooms. And I'm going to look for the parameter of level with a capital L. This will return the name of the level, not the level element itself. Which is perfect because we can compare this to the list of levels that we've just generated from our user interface. So I'm going to go up and just split all my data up using a code block. So I'm just going to call my data. I'm going to name it as a variable, and I'm just going to split it up into rows. And I'm basically just splitting all the data from the various indices that the data occurs at. Now each row will be a single variable as it comes out the other end of my interface. In this case, data4 is a sublist of the levels that I'm looking at. I can now run this over a list.contains node to check if each of those levels occurs in the levels that I selected. So in this case, my list is going to be my placed rooms. Sorry, no, my list is actually going to be my data shapes input. And I'm checking this as a list. So I'm checking this at level 2. And then checking every occurrence of the level of each room as an item. So for each level of the room, does it occur in the list of what I've nominated? By default, I'll only get 1 result. I do need to set this to longest lacing. Once I do that, for every single room, I'll get a match of whether it occurs in the list. I can then use my favorite Dynamo node, filter by Boolean mask, to filter my rooms with those Booleans. And now the in list from here will represent any rooms that belong to those levels. So I've got a cat whizzing around in the background. So at this point, I might just block this off as a group, because I find sometimes it can be easier to maintain things if we just keep them together. I'll just block off my user interface. And I might just also block out my main UI as well. So at this point, we can proceed with the rooms that actually are relevant to our study. Now at this point, I'm going to obtain the finish boundary of those rooms. So I'm going to look for room.finish boundary. And if I run, we should get all the curves of those rooms. Now note that some of them might occur at different levels depending on the levels that you've selected. I can see in this case a couple of them are down on the carport level. You might also have rooms that have loops inside them as well. Let's say you have a room that's like a donut shape. Well, in this case, we're just going to call the donut shape in the middle part of the room. It may not be necessarily appropriate to every project, but unfortunately I haven't found a way to cut holes out of shapes in shapefiles themselves. I'm sure there's probably a way, but I haven't found it myself. So what I'm going to do with this finish boundary is I'm going to join them into polycurves. And I'm just doing this to make sure that they all occur in an order that is going around the shape. So I'm going to make a polycurve by joined curves with a tolerance of 0. And now we should have ideally one polycurve per room. Now let's say we actually have more than one polycurve. Let's go and introduce some room separation lines into one of our rooms, say on the driveway. Now I may need to rerun this script to do this, or I might just need to refresh my room. So I might just put a Boolean toggle on the refresh statement for room by placement. And yeah, it's going to trigger a change in the interface. So I'll just really quickly refresh those values. But we should now ideally see that hole appear in our garage. Ideally. In this case, of course, because they're not down on the carport level. So if I paste this to the carport level, that should, there we go, that bounds the room with a hole in it. So again, I might need to reset. That is the challenging part. If you do set up a data shaped UI from the very start, it may refresh here and there. But now we can see that this carport actually has 2 polycurves instead, which is a problem. We just want the biggest area polycurve out of those. So what we're going to do is just disable the preview of our finish boundary. And we'll just also disable this preview. And I'm going to generate a surface patch for each of those. So from these closed curves, I'm going to make a surface. And the reason I'm doing this is so I can check their area. So from here, I'm going to get a surface area node. And I want to find the surface that has the biggest area, because I know that this will be the surface, or this will be the polycurve that represents the outside of my room, which will always have the biggest area. I'm now going to sort each of these lists of polycurves with the keys being the areas, and the last element in each list will, as a result, become the largest polycurve. So if I sort the list at level 2 as a list by the keys as lists, so both at level 2, in this case I believe I might need to just revisit one thing. I'll just check the lacing I have here. So we have keys, we have lists. In this case I believe actually we need to sort this way. So in this case I think I've actually triggered an issue here. I'll just quickly check the size of my lists. So I think I may actually need to sort at level 3 because all my elements occur one level deeper in this list. So I actually want to measure at this level. Once I turn these into a polycurve, everything goes one level shallower in the list structure. So I'm actually working at level 3 here, sorry. And now we should have a sorted list. And in this case, the last list will represent the largest polycurve. So what I can do now with these is I can take the last item from each list. So I'm going to get last item. And from these lists at level 2, so working at each list level, I'm going to take the largest polycurve. Now in this case, I think I need to work at level 3 again. And now I should get the set. So notice now this hole in the garage has been managed out. So this makes sure that you only get one large curve related to each room. At this point, I like to pull these onto a common plane. So I use the pull onto plane node in this case. I'm going to pull these curves onto the XY plane. So I'll just get that plane in the XY. And this will solve all of our elements not sitting at the right level. Now they're all consistently aligned in the Z direction. Now the next part's a little bit tricky. So now we have a lot of arcs and splines. Now this is a problem. To build polygons, we're going to need to actually turn these into segments. So this is where I'm going to use the algorithm from Pierpaolo Cunini. And again, thank you for his help. And I've roughly figured out how the algorithm works as well. So I'll try to talk you through the logic of how it works as I go. So first of all, just to make things easier, the first thing that I noticed Paolo did is he collected everything into just a single variable. Now you don't have to do that. You could start from this node instead. I do agree with the way he did this step because it means you can more easily move around this block of code without impacting all the other wires in your script. Now at this point, each sublist will contain lots of different types of geometry objects. They're all typically curves, but we're going to check what types of curves they are. So I'm going to get an object type and see what types of objects these are. And if I go to the end of these descriptions, actually at the moment they're all curves. So I believe I may have missed something here, because I think some of these things are going to be arcs, for example. So I'll just double check that I'm working at the right level here. So I think at the moment, yeah, some of these things are arcs and then curves, which is intriguing. Interesting. Yeah, they're all being treated as curves in this case, so I might just double check what happens if I don't pull onto plane. Now they're all arcs. So I might pull onto plane just a little bit later instead. I think that's probably safer. So for now, I'm just going to keep this off to the side. And this way we can now look at the raw geometry type. So now we can see arcs, lines, splines, all sorts of shapes, different types of curves. But what I'm going to do with this is just check for the ones that are lines, which will be most of them. So in this case, I'm just going to say, does type, I'm going to check if type doesn't equal, and I'm going to say, does it not equal autodesk.designscript.geometry.line. And this will generate a mask that I can use in an if statement. And this will all be working still at the same levels that we were handling before. I'm also going to check the length of each of these curves, because I want to find out how many segments I'll need to divide these by in order to meet the number of divisions that we're going to apply to it. So now I can see the length of every single curve in each of those polycurve boundaries. I'm then going to grab a code block, and I'm just going to say this is len on seg, where seg is the number of the segment length. So I'm dividing the length by the segments, and this is all the way back here in our user interface as our second output at index 1. So I'm going to go and retrieve that value, and now we'll have a number representing the number of segments that would be required in order to divide to that length. I'm going to be applying a ceiling, so I'm going to be rounding up here. So I'm going to get the ceiling node, just to make sure that we achieve the segment length. Now we have whole numbers in this case. So this is pretty much what we would desire. Now in this case, we need to check for a condition here. So if the element is a line, we're going to want to divide this element into two segments, a start point and an end point. Anything larger than that, and we're going to want to be dividing by more than that potentially. So in this case, I'm going to say if the object is equal, and in this case CE I believe was the ceiling, we're checking if it's the ceiling, then 2. So we're going to be passing through either the ceiling or 2. So if it's true, it's going to, I believe, be, so if it's false, it's going to be 2, and if it's true, it's going to be the ceiling. So we're going to pass in this case, our ceiling and our object. And this will substitute any value that would have been a certain value otherwise with 2 to get a start and an endpoint for each of those curves. We're going to turn these all into sequences. So from 0 to 1, by the number of segments. And we're going to use this as our segment value. Now each of those numbers will form a sequence. For a line, it's just 0 to 1. For anything else, it might be more segments in between. And these are all the parameters along the curve that we're going to want to place a segment point at. We also need to now restructure our lists as well. So we are going to count how many items are in each of our curve lists at the start. So from our initial list of curves, we do have to count at level 2. And this is because we're going to be re-chopping our data later on. But now we can see how many curves are in each of our sublists. We're now going to be working with curves and points at parameter along the curves. So we're going to go curve.point at parameter. So we're going to take our original curves all the way back here. And we're going to be working at level 1. We're going to be working just with each curve. So we'll take curve at level 1, and we're going to work with the parameters at level 2. So for each curve, we have a list of points. So the list corresponds to the object. We're now going to take those segment parameters in order to divide these curves. And we can now see that anywhere where we have a straight line, we have a start and an end point. Anywhere where we have a curved element, we've obviously passed this through the if condition in the code block, and it's generated those segments at equal segment length. So it's a really cool algorithm, and I really appreciate people sharing it as well, because it really unlocks this workflow. All we need to do now is just restructure our data, because at the moment it's not quite in the right data structure. We're going to be applying a data chop in order to get this back in the right shape. So we're going to take this data and chop it by the lengths that we counted back here, so that we can put these back into sublists that represent each individual set of points along each segment of the overall curve around the room. From here, we're just going to be flattening this. And I'm going to flatten each list at level 3 in this case, so that we're just taking it right down to every point within each curve that goes around each room. And from these, we can form a polygon. So it's a really neat little workflow, but a little bit complicated. So I hope that that sort of made sense as we went through. I'm just going to go back and hide a couple of these preview elements that we went through with. But from these, I'll just go, actually I do need to prune duplicates as well, because we do have some start points and end points for each curve that will meet at each other's start and end point. So we do want to remove those specific instances. So this will prune from each sublist and just give us a unique set of points. And from these, we can generate a polygon. So I can now go and find polygon by points. And now I have segmented representations of the outside of each room. So really cool. And these will be allowable to generate an SVG or a shapefile. So really handy. And we're pretty much actually almost at the end of our workflow. Now, one interesting thing that happens in Power BI when you import the visual is that the geometry is actually mirrored. So you're looking at the bottom of your floor plan essentially. So what I typically do at this point is bring in a geometry.mirror node. And I'll take these polygons and mirror them across the XZ plane. And we might also just go and pull these onto a plane as well, because I believe these are still, yeah, they're not at the same level still. So I might go back and just retrieve that pull onto plane that we had from before. And I'm going to pull that result onto plane. Just make sure these are still polygons. So I believe in this case that turned them into curves. So we don't want to do that. So what I might do instead, yeah, I think I might have to move the points. So we're going to pull those points onto plane instead. I'll just see if we've got a pull onto plane for points. I believe we did. Okay, there is one for. I've got a little trick I can use here actually. So what we're going to do is take each point and we're going to say pt, I hate when it does that. We're going to go .x, go back and write pt as a variable for point. And we're just going to go .y and PTY. And we're going to get the Y and the X value for each of those points. We're going to ignore the Z value. I'm going to create a point by coordinates. Point by coordinates. And I'm just going to use X and Y and leave Z at its default of 0. This will essentially pull onto plane as well. I believe there might be some geometry scaling challenges we might face here, so I might just go to geometry scaling and just move up one level to large. Of course it triggers the restart, so I'll just populate those variables again. Carport, ground floor, below ground, generate. Okay, that looks better. Now I can form polygons at the same level from those points instead. Just turn off this preview. And that should work instead. So now we don't need to pull. Yeah, we shouldn't have to pull onto plane anymore. Perfect. So now we have a list of polygons, and this is perfect for exporting to an SVG file. So I might just go and group this block together, just so it's a bit easier to see what we're doing. And I always recommend that you try to go back and rename and add notes to things as you go. It'll make things a lot easier to follow for other people. In this case, we're just going to be using the SVG export node, and this is from the Illustrator package. So we're going to be using a few things here. We're going to be exporting some geometry to a location based on a file name. So this is our directory, and this is our file name. Viewport width and height, I typically just set to an arbitrary number. I don't believe it matters what it is, to be honest, so I'm just going to ignore it in this case. And by default, the units are measured in pixels, which is what I've been using as well. So we'll take our polygons, we'll take our export location, which is our directory, which is the first output of our input list. We'll then also go and retrieve the file name, which I believe in this case was the third input. And that should be it. We're ready to export a shapefile of polygons from our file. So I believe at this point, we should just be able to run this and hopefully everything will work just fine. So I can see that my shapefile is just exported. So I should have a raw data.svg file. I'm just going to use Notepad++ just to quickly inspect this file and just make sure it looks right. Great. So this is our shapefile. So we've pretty much reached the end of part 1. But one challenge you'll see is that the shape elements don't have any information attached to them. They don't have any element IDs or names. So we couldn't connect these in Power BI right now. So in the second part, we're going to be focusing on how we can splice data onto these in order to create a visual in Power BI. So in part 2, we'll be splicing. We're going to write the room data to Excel, and we're going to use all of this in Power BI, as well as a synoptic panel visual element to create a Power BI report, and it's all connected. So I hope that you enjoyed this presentation. The files will be on GitHub. I'll upload the final script after part 2. So if you are waiting for the script to follow along, just wait till the next part comes out. And in this case, it looks like my home slide might have dropped off. So I'll just go back to the first slide. So thanks for watching part 1. I hope you found it useful. I know it was quite a long and complex workflow, but for those that stuck through and persevered, thank you. And I hope you've learned a lot about how you can process data and also geometry in Revit. Thanks again to the people that gave me some of these ideas, and I look forward to showing you part 2. If you're not already following and subscribing, feel free to do so, and I look forward to seeing you in future videos. Thanks. Take care.